Yes. Yeah, and let's begin. Haim.
Yes, I'm sharing my screen and we'll start. Okay, do you see my presentation?
Yes.
Yes.
Okay, thank you. So welcome everyone. My name is Haim Cohen and I'm a tech leader in the data domain as part of the backend group in Tikal. I've been working in the data field for the past 10 years and it's been a significant part of my work. As Tikal engineers, we are exposed to a large number of consumers in various domains and diverse technologies, which gives us a broader view of the trends and shifts in the tech world. Therefore, we are constantly researching the future of technology, and we share our insights with the community in the form of Take Radar. The radar details tools and trends in the domain of backend, frontend, DevOps, and mobile, and divides them into rings, where we recommend to try, start, keep, and even stop using certain tools according to what we see in the market. The radar is published on Tikal's website and being updated periodically according to the status of the market. Recently, I've been researching myself the trends of the world of data, and I found a famous quote of Tim Berners-Lee that says, "Data is a precious thing and will last longer than the systems themselves." And I feel it reflects greatly the significance of the world of data, and it's relevant. It is relevant today more than ever. In order to understand the current trends of the world of data, we should review and understand the forces that influence this world. Well, first of all, we have the growing mass of data. With social media, in which great amount of content is generated by billions of users, and sensors and IoT devices which generate infinite pieces of information, the global data volume is doubled every 3 years. The challenge of collecting, storing, and analyzing such an enormous amount of data has become a main technology challenge in the past few years. Another influencing forces is the growing demand for data. Organizations are realizing the insights that are hidden in the data, which allow those organizations to upgrade their business. There is a growing demand to store and use data to improve business performance. We also witness the complexity in the markets and the increased competitiveness. Companies are taking every advantage they have to win the race, and one of those profound advantages relies on data. Another quote by Jeffrey Moore, a consultant and author, describes it well. He says, "Without big data analytics, companies are blind and deaf, wandering onto the web like a deer on a freeway." Well, in light of those forces, the following trends are emerging in the upcoming year. First of all, we have continuous intelligence. We are in a phase that is beyond models that just are trained over past data and perform prediction on new information. Today, the models are far more sophisticated and taking into account the user's immediate response, which creates an automatic cycle of model fine-tuning. We can already see it working in, for instance, Google search engine, which learns our search patterns, or Amazon recommendation engine, which learns our acquisition patterns. Smaller companies are also starting to incorporate such capabilities. Data democratization. Data is no longer used exclusively by analysts and data scientists within the organization. We're witnessing more companies in which the data consumers are far more diverse. Departments such as monetization, marketing, and even accounts use data wisely to improve performance and increase revenue. Organizations are encouraging various teams to use the data, increasing the rate of data within the organization. Data meshes. Data is no longer a byproduct of activity. Data has become the product itself. And we see more companies that hire product managers, which are in charge of the data products and are specialized in products such as data lake and data warehouses, and design them to serve better the various needs of the data consumers. DataOps. DataOps is a trend that already exists for quite some time, but is intensifying lately. The DataOps, in DataOps, we see DevOps methods from the programming field, such as CI/CD, that are applied on data products and help develop data pipelines, which are the backbones of the data products. All of these trends are compiled into a single term, which we called data as a code, which signifies the change in the world of data and treats data as a first-class member, much like code in the software development arena. As part of these trends, we are happy to host Martin Traverso to talk about Presto. Martin is a co-creator of Presto and the CTO of Starburst. Presto is one of the most popular engines to crunch and analyze huge data from various sources efficiently. Martin, you're welcome.
Thank you, Haim. It's a pleasure to be here. Let me share my screen. Can you guys see that?
Yes.
Yes. Okay.
Yeah.
Right. Well, thanks for having me here. It's a pleasure to have this opportunity to tell you about Presto. Is a project I'm very, very passionate about. I've been working on it for the last 8 years of my life. So my name is Martin Traverso, and I'm one of the creators of Presto. I'm currently CTO at Starburst. We're gonna go over what is Presto. I'm gonna tell you a bit about about Starburst very briefly, and then go into the architecture and some of the more details about how Presto works and why it's fast and how it works under the covers. All right. All right. So what is Presto? I imagine some people are familiar with Presto. At least you've heard of it. But if you haven't, we'll talk about it now briefly. So Presto is a distributed SQL analytic query engine. It's so just like I mean, unlike database like Oracle, MySQL, etc., it's designed for analytics. It's not designed for transactional queries. It's been used at companies like Facebook for many years. That's where we created it. It's been running at large scale at those companies. It's been adopted by a bunch of other companies over the years. But I mean, basically, it's able to run at very, very large scales with thousands of nodes, and it's been proven to be able to support thousands of users over data sets that are large in the orders of petabytes and even close to exabytes at this point. So the engine is designed for, it was originally designed for analytics, for interactive analytics. Over time, it kind of morphed and it evolved into being able to support other use cases, but that was the primary use case in the beginning. So the idea is that it can respond to queries in the order of a few seconds to maybe a few minutes over data sets that range in the low end gigabytes to petabytes at the high end. So it's very, very fast and efficient. So one unique feature of Presto is that it decouples computation from storage. And I mean, it's not a new or novel thing, but it's something that kind of came about in the architecture of Presto. And this is very powerful because it allows you to scale the computation and the storage independently. For example, if you have more data, you can add more data to your storage system without having to increase your capacity in the query engine in Presto if you don't need to. And then you can increase capacity in your computation layer as the workload increases, and you can scale it down as the workload increases. So this allows you to very flexibly manage cost and performance in your infrastructure. So Presto is primarily a computation layer. It doesn't have storage by itself. It can connect to data sources via extension points that we call connectors. And these connectors allow Presto to read data from different data sources. It could be from object store like S3 or HDFS, or SQL databases like MySQL, Postgres, Oracle, etc. One very interesting feature of Presto is that it can run queries in what we call federated mode, which is within a single query, you can refer to tables that come from different data sources. You can pull data from, say, a MySQL database, join it against data in your Hadoop data lake, and then do that on the fly and without having to copy data from one system to another. Presto has been around for some time now. We created it in 2012, and we open sourced it in 2013. Initially, it was adopted by some of the large Silicon Valley internet companies like LinkedIn and Netflix and so on. And then progressively, it got adopted by more and more companies all over the world and across many industries. Here you can see some of the companies that use it today. And by our very unscientific count, like, it's being used by thousands of companies across the entire world right now. It's open source. So we've been running it as an open source project from 2013. We designed it from the beginning to be able to open source it. And kind of the connector architecture is kind of a consequence of that. I'm not going to go into too many details about why, but that's one of the things that we had to do to be able to make it open source and flexible enough to be able to be used inside Facebook, and at the same time be able to be used by other people in the community. So the community has been growing very, very rapidly, like in the past couple of years, especially. Right now we have about 3,000 members in our Slack group. And here's a link if you want to join it later. And out of those 3,000 people, there are 500 people that are active every single day. So this is one of the most active open source projects I've been involved in. We have a community that's global. We have developers and users all over the world. Last year alone, we did conferences in the US and also in Japan, India, and Israel. We were in Tel Aviv in April last year, where about 250 people showed up to hear about Presto and how different companies use Presto over there. And it's a very vibrant community, and the rate of contributions and the rate of involvement has been growing very rapidly too. In the last 18 months or so, we've seen about 25% of all the contributions happen to Presto. So over the last 8 years, just in the last 18 months alone, more than 25% of the changes happen. So this is like, it's moving very, very quickly. We do releases about every 2 weeks. So it's moving rapidly. So very briefly about Starburst. So Starburst is a Presto company. It was founded in 2017 by the leading contributors to the project and the creators. We're growing very rapidly. So far we've raised 64 million from venture capital here in the Silicon Valley. And we offer an enterprise version of Presto, and which brings value to customers in a bunch of different areas. Like, for example, it simplifies deployment and management of Presto on-premise and across different clouds. He has advanced security features such as data masking, access control, and so on. And then integration with security systems like Okta, Apache Ranger, and other platforms. We also have high performance implementation of several connectors and connectors for data sources that are not available in the open source version. And of course, like we're the company that employs the people are most familiar with Presto, and we offer 24/7 support for our customers. Right now, we have more than 100 customers across many industries. Some of the names you can see there, you may be familiar with. So going into the architecture, kind of digging under the covers here. So Presto runs as a cluster of machines. There's one machine that acts as a coordinator and a number of other machines that act as workers. So the coordinator is responsible for taking the query from a user, doing all the steps for parsing, analyzing, planning the query, optimizing it, and then initiating the execution of the query across all the workers. And it coordinates the execution throughout the duration of the query. The workers are the ones responsible for actually reading the data, processing it through the operators, say doing filtering, doing computations, aggregations, and joins, and so on, and then presenting the data to the client. Clients can be, there's a variety of clients. Like we support a bunch of BI tools. So the interface to Presto is via it's a simple HTTP interface, it's a documented protocol. And we have clients in many languages, JDBC, ODBC, and then specialized clients for different languages like Python and R and Ruby and so on. So very quickly, so when the query gets into the coordinator first parses it, analyzes it, it uses metadata to be able to do this. It needs to know what the tables are involved, what tables are involved in the query, what data types, what columns and data types. You make sure that the query is semantically correct. Like for example, if you have a group by query, an aggregation query, you need to make sure that the group by keys are present and so on. Then uses that information to hand it off to the planner, which turns that query into an internal representation that is easier for the optimizer to reason about. Then that plan goes through a series of transformations to produce a more optimal plan, and that final plan is then used to schedule the work across the workers. So the workers then basically form a mesh of workers talking to other workers to read data at the bottom from the underlying data sources, and then as it streams through the system from worker to worker. So I mentioned Presto is extensible via connectors, and the way this works is I said the parser and the coordinator needs to access metadata API. The workers need to access the data source to read data. Behind those APIs, there's an implementation for each of the connectors. For example, we have connectors for Hive, Cassandra, Elasticsearch that allow you to read data from say for Hive is from S3 or HDFS following the Hive data layout. You can read data from Cassandra or Elasticsearch, and those systems need to provide metadata about their tables, the tables they support. So each of these connectors implements one of these or a series of APIs that the engine can interact with. So everything is abstracted as a table, and then Presto can interact with those data sources by asking for that metadata and then asking for the contents of those tables as the query executes. So we have connectors for, these are connectors that come with the Presto open source version. We have connectors for many systems today. Of course, we started with the HIDE connector, what we call the HIDE connector, which is the connector for interacting with the HIDE Metastore and HDFS and S3. That's kind of the workhorse of Presto, is the one that's the most optimized. And it's the connector that you use when querying data in a data lake that follows Hive's data layout conventions. We also have connectors for a bunch of other NoSQL data stores, like Druid, Accumulo, Cassandra, Kudu. So those are have various degrees of flexibility and power, but you can connect Presto to those systems. You can read data. You can join it against data from different data sources. And then we also have a couple connectors for some streaming systems like Kafka and Kinesis. This is super powerful. It allows you to treat Kafka or Kinesis streams as tables. You can query and see what's going on right now in those tables. And then of course, you can also join them against other data sources. So this is very, very powerful. And then finally, we have connectors for a bunch of SQL databases like MySQL, Postgres, Oracle, and so on. All right, Presto is designed, as I say, is designed to be very fast, very efficient, and scalable. At the top level, it has a cost-based optimizer. This makes it easy to write queries without having to worry too much about in which order you specify the joins, whether you put the filters in one place of the query or a different one. So Presto will take the query, will optimize according to stats in the underlying tables, according to a number of heuristics of what's fast and what's not, and produce an optimal execution plan. So this increases the usability of the system without having to. So unlike if you're building a data transformation pipeline by hand using a programmatic API, you don't have to worry too much about how you structure it. Presto will figure out the best execution plan for you. The optimizer can also reason about the shape of the plan. Specifically, it can do things like take predicates and column projections and computations, and even some more advanced computations like aggregations, and push them into connectors via these connector APIs. So you can interact with the connectors and figure out what parts of the query can be pushed down to the data source, which may be able to execute them more efficiently if it has the right data structure. For example, if you're querying a system like Druid has pre-aggregated data. You can, so it's more efficient to just let Druid provide the aggregated data that is pre-computed, and then Presto continue with the remainder of the computation. And the same thing with SQL databases. They may have indexes. They may have optimized paths for certain computations. So it's better when Presto can push that computation down. So at its core, Presto is a MPP style pipeline execution system. So MPP stands for massively parallel processing. So this is a traditional architecture for analytic databases. And what that means is that as Presto reads data and data is fed into the different operators, as soon as those operators complete the computation, they forward it on to the next operator, and so on. So this helps reduce latency for query execution. It can better utilize the available resources because it doesn't have to wait for a computation to be completed, written to temporary storage, be read later, and so on. Presto is, I mean, it's because it was designed for interactive analytics. We had to make sure it was fast and efficient, which it does by through a couple of techniques. One of them is it can take when it takes a query, after it plans it and it starts executing it, it compiles it into specialized bytecode. Presto is written in Java. It uses the JVM as the underlying technology. So it can compile queries into specialized bytecode, which the VM can then compile into native assembly code, and you can it can optimize it and execute it more efficiently. And it also has optimized memory data structures for data that flows through the system. Specifically, it stores data data when data flows through the engine, it flows in columnar format, which makes it more amenable to vectorized execution, which in turn makes it easier for the VM and the CPU to be able to process that data efficiently. And then of course, Presto can run across it can take advantage of multiple cores, multiple threads, multiple machines, even for a single query. So it can split and parallelize a query execution across multiple machines to speed up the processing. So it's very common, like if you have a query that processes a lot of data or uses a lot of CPU, if you add more machines, the query will generally be faster. So you can scale your performance by scaling your cluster. And it's also designed for high concurrency. So you can run multiple queries by multiple users at the same time, and the system will share the resources in a fair manner and make sure that all the queries make progress and basically minimize latency. Then at the bottom, especially for when interacting with data lakes and with formats like ORC and Parquet, Presto has a set of optimized readers for those formats. So it doesn't use the stock readers that Hive and Spark and other systems use. It has an implementation that is optimized for the way the Presto engine works and the way it thinks about APIs and data. So there's less of an impedance mismatch and less loss of performance for that layer, which is very important because that tends to be for typical workloads, that tends to be the place where the queries spend the most time. So by optimizing that layer of the system, we can get better performance. Very briefly, some of the use cases that we've seen over the years. So Presto started as a system for doing interactive analytics over the Hadoop warehouse at Facebook. It was intended to be a replacement for one of the uses that people applied Hive to. Like they were trying to do interactive analytics. Hive wasn't very good at that, so we built Presto for that. Over the years, like it evolved into other use cases, especially as we added the ability to connect to different data sources. So eventually, people end up using for dashboards, for very low latency dashboards. There were a couple of applications built on top of Presto at Facebook. One was user facing. It was for doing advertising analytics. So this was an application where Presto had to return in responses in a matter of a few hundred milliseconds to a few seconds when running queries that did like 15-way joins or very complicated queries. So we optimized the engine, we optimized we implemented some new connectors at Facebook to be able to support that. There were other uses like the backend for the analytics A/B testing system at Facebook was built using Presto, and this had to be able to crunch through billions of rows representing users and trillions of rows representing events that users performed, and it had to do this in a very low, reasonable latency, like in the order of a few seconds, like 5 to 15 seconds or so, because there were people sitting on the other end trying to look at the results of these analysis in real time. And then over the years, we ended up applying Presto to ETL and batch workloads, and eventually replaced the majority of the workload where Hive was being used at Facebook. One of the things we've seen, especially in the industry at large, is people started adopting Presto for cases where they were trying to do query federation, where they had different data sources. This could be because companies acquire other companies, so they have data silos. they have data spread across different systems, and they want to bring them together to be able to do analysis without having to copy data from one place to another. So Presto brings that power because of the ability to connect to different data sources and the ability to join them in the same query. So that became one of the defining characteristics of Presto, and it's one of the things that made Presto so popular over the years. Right, Presto can run across multiple environments. It was originally designed to run on bare metal machines at Facebook, but we designed it to be independent of the environment where you run it. You can run it on premise, in different cloud environments. Actually, that's one of the things that also made it easy for people to adopt and made it popular over the years, is that it was easy to take it and run it on different environments without having to specialize much for each specific environments. Starburst in particular has offerings of the enterprise version on different clouds, AWS, Azure, and GCP. And we also have a version that runs on Kubernetes clusters. So if you're running a Kubernetes cluster, it's easy to deploy that way. We have a Docker image. So if you want to try it out, it's very easy. Just run that image. It comes with a couple pre-configured connectors, and then you can, of course, extend it and configure with other connectors if you want to use that as the basis for your production deployment. A typical cluster in Presto has anywhere from a few tens of nodes to hundreds of nodes. At Facebook, we used to run clusters of up to 800 nodes at the large end, and maybe 10 or 20 nodes at the bottom end. And across the industry, like different users have clusters in this range also. Presto can, as I say, is very efficient in terms of processing data, churning through data, and it can use all the CPU in the machine, which means that you have to be able to read that data fast enough from your remote systems or underlying storage, which means you have to have fast network. So if you're deploying Presto, make sure you have a fast network. Typical, recommendation is 10 gig networks at least. You can run with smaller networks, but you may be idling CPU if you do that, like depending on the shape of the queries. And depending on the kind of queries you run, and depending on the number of users and the number of queries you're running at a given time, you may need more memory. So the more memory, generally the better. So if you have to trade off number of machines for memory, aiming for a lower number of machines with more memories in each machine tends to be better, because it allows Presto to use the memory more efficiently. There's less wasted overhead across multiple machines and so on. So it's kind of a simple rule of thumb. But any of the machines available in the different clouds tends to be a good fit. Like you can pick a machine with 128 gigs of memory, 256, and you'll be good. Right, looking at the roadmap briefly. So the Presto is a community-based project. It's based on contributions by volunteers, either people working at different companies that happen to be developing Presto, or people that just do it for fun. And as such, the roadmap is very dynamic. It depends on what people are willing to work on at a given point in time, what the different priorities are for different people involved. And so it changes all the time. But right now, the things that we're looking at, these are projects that are going on right now that we expect to land in the next few months. One of the biggest ones is we are adding support for the update and merge language features in SQL. And this is very important because, traditionally Presto supported reading data from tables via select queries or inserting data. You could create tables, insert data, but there was no way to update the rows inside a table. And this is primarily because none of the storage systems that Presto traditionally interacted with supported this. especially around data lakes. Like Hive didn't support this. There are other systems that started becoming popular over the past year or so, maybe a couple of years, like Apache Iceberg, Delta Lake. Hive added support for transactional tables. So these allow for mutating rows inside those systems, and that makes it a more compelling feature to add. So we're working on that. It can be important also for people that are running like with all these regulations, like the privacy regulations that require that you delete data within a reasonable amount of time. You need to have the capabilities in your data analytic systems to be able to get rid of that data. So this will make it possible. Then we're adding materialized view support. This is like the feature similar to commercial databases like Oracle or Postgres. And this will allow people to new ways of modeling how their tables are related to each other. And then, of course, in turn, it allows or makes it possible to do certain optimizations by being able to reuse pre-computed data when running queries. So this opens up the door for better performance in the future when Presto is able to take advantage of materialized views. The third project is we call it dynamically resolved functions. And this is the ability for connectors. So today connectors can resolve tables dynamically. When you run a query, you say select from some table, that table is resolved at that moment against the connector, and the connector provides metadata for the table. So we're doing the same thing for functions. Like traditionally or historically, functions have been fairly static in Presto. You can write new functions, but you have to deploy them with a Presto server when you start it up, and that's it. If you want to update the functions, you have to restart the server. So we're making the Presto be able to resolve those functions dynamically, so they can be added and removed dynamically as the system is running. So this opens the door for example, being able to define functions in other languages, like in scripting languages, JavaScript, Python, etc., or allow connectors to source the implementation of functions from remote systems. So you could have, for example, a layer that knows how to load functions from your Hive system that got deployed and expose them to Presto in some way. So this adds flexibility to the system that it doesn't have today. And then final project is, these are not all the projects that we're working on, but the most important ones. So I mentioned that we have a optimized Parquet and Orc reader, but there's still room for improvement. So we're working on improving one of the layers of the Parquet reader. This will make some, at least the parts that of the query that read Parquet data to be about 4 to 5 times faster and more efficient. So this should improve the performance for anyone that's using Parquet data, which is pretty common, especially when people are running on AWS with S3. That tends to be the format of choice when dealing with data lakes. Right, and Presto, of course, an open source project. I'd like to invite everyone to join the project. If you're a developer and you want to contribute to the project, there's a good way to get started. We have issues that are tagged with this good first issue tag on GitHub. So those are kind of a good way to dip your toes and start getting familiar with the system. If you're not a developer, if you're a user, it's also very useful when we get bug reports or people talking about what features they need, what pain points they have, because it helps the project and the people involved in the project figure out, okay, this is important and we should spend time working on things. So we have a Slack channel, a Slack group, and for Presto, there's a link there. There's a channel for troubleshooting. So if you're a user and you have questions about running into problems, that's a great place to interact with other community members and the developers in the Presto community. And then if you are running Presto today, if you want to talk about how to use Presto, we have a community blog. So, and we welcome people to write blog posts and publish them there. So you can follow that link there. And then finally, I would like to leave you with a few resources. If you want to learn more about Presto, there's a book that we published earlier this year, and it's an O'Reilly book about Presto. You can get a free copy courtesy of Starburst through that link. If you want to get into more details about how Presto works, the architecture, some of the reasons things are done a certain way and so on, we have an academic paper we published last year. You can, there's a link there, you can get it. Of course, there's the weblog. It has articles ranging from low-level details about Presto to how people use Presto, use cases, and so on. So it's a good source to follow if you want to learn more about the community and how people are using it. And recently we started we call the community broadcast. It's a show where we talk about what people are doing with Presto. We talk about what's events and things that are happening in the community. Sometimes there's discussions about specific features and kind of going into details. So that's, we have, I think, like 4 episodes right now. So that's also a good thing to follow if you like that. Okay, and with that, I'm done. And if you have questions, I'm happy to answer anything.
There is a question in the chat by Alon, says, can you please share sizing recommendations? How can we measure how many nodes and their size?
That's one of those, the answer is, it depends. There's no good straightforward answer to that one. It depends on a lot on what kind of data are you accessing, what kinds of queries you're running, how many users you're going to be supporting, how many queries you're going to be running at a given time, and so on. I would say, like, to start with, the thing is, it's easy to, especially if you're running on cloud environments, it's easy to try with some cluster size. You can pick some machines like kind of middle of the road in terms of memory and CPU, and pick a few machines and then run your workloads and then take a look at how is the CPU being utilized. If it's if you're maxing out the CPU, then there may be opportunity for increasing the number of machines and speeding up your workloads. If you're not getting the latencies you want, you can try increasing the number of machines. Of course, if you see failures, that's like there are specific types of failures. That could be an indication that there's you don't have enough memory, for example. And in that case, you will need more machines or more memory per machine. So there's no straightforward answer. I would actually like to point you to, there's a blog post in the Presto blog link I posted that where we did a training where we go into a lot more details about what are all the factors you have to consider. It's like a 2-hour training about like how you tune Presto, how you size it, how you plan for capacity and all that. So let me find that. I'll post in the chat in a moment. So in the meantime, if there's any other questions.
Yes, I'd be happy to ask one. I'm Yaron, VP R&D of Clinch. I wanted to ask, in Amazon AWS uses Presto as the Athena product. And I was wondering first if there's any plan for other cloud providers like Microsoft or Google to have similar products, if you are aware of this. And if you know what's the plan for AWS to update Presto, what's the current version? How far is it behind the recent releases?
Yeah, I mean, I don't get much visibility into what different cloud providers offer and I mean, what their plans are around their offerings. I mean, I know that EMR recently started supporting, in the last version of EMR, they started supporting one of the recent versions of Presto. So it's still a few releases behind. I keep in mind that we do releases every 1 to 2 weeks, and cloud providers they can't keep up with that. So I don't have much visibility into that. On the other hand, it's actually fairly straightforward to deploy Presto if you need to do that. And if you go with, for example, you look at Starburst, there's an offering there. You can use that. We have a partnership with Google to support our offering on Google Cloud. We have a partnership with Azure also. So you have that choice there. Other than that, it's kind of roll your own. I think Google supports Presto in Dataproc. And
yeah, I see that right now. Yes.
Yeah, they support it there. I don't know what version they support right now, but I think it's also very straightforward if you want to have a custom version running there.
Cool.
I believe that Google would like to push BigQuery forward, so I guess they're not that anxious to use or to support too much of Presto. This is my feeling. I'm not an authorized person of GCP to say that, but I believe that is their goal.
They've actually been very, very open to adopting Presto. I mean, for example, they contributed the connector for BigQuery. So that was Google developer contributing the connector for BigQuery to Presto. So, I mean, at the end of the day, I think those providers, what they want to sell is their cloud and hardware. So the more users they get, it doesn't matter how they get it, the better it is for them.
That's true.
Thank you.
By the way, I just pasted the link to that training that talks about performance. So you look at that, it goes into a lot more detail about how you reason and think about sizing your clusters.
I have a question, Martin. I try to understand the difference between Presto DB and Presto SQL, if there is any difference.
Yeah, there is a difference. So Presto DB is the project. So when we left Facebook, we basically formed a separate project. We set up the Presto Software Foundation and as an independent foundation, and Presto SQL is the fruit of that. And that's where the original creators of Presto and the majority of the original maintainers and contributors are focused on right now. Presto DB is a project that Facebook is developing. They continue to support it on their own. So Presto SQL it has evolved significantly over the past couple of years. We've had many new features and contributions, and there are many companies involved, like we have Starburst, LinkedIn, Netflix, Qubole, Varada. There's a lot of other companies involved in that project. So it's basically where the community is centered right now.
Okay. Any more questions?
Can you put the link to the book?
Link to the book. Yeah, we'll share the slides after, but yeah, I'll make the slides available and you can grab all the links from there.
Thank you.
Maybe from an inside view, could you compare the implementation with competitor open source implementations?
Like which one, for example?
Well, I wanted to leave it open to you, but let's name one, like Spark SQL.
So Spark is I mean, they kind of serve similar purposes. Yeah, it's SQL over like you can do over Hive data or data lake data. The architectures are different. Like Spark is closer to MapReduce architecture, and so Spark is not like a traditional MPP system. Presto has one of the differences that in Presto the execution happens all in like concurrently in a pipeline manner. In Spark, Spark divides according to different stages, and stages need to complete before the next stage completes or starts. So that can introduce latency to the execution. Presto does all the stages at the same time, and data flows through stages as it becomes available. So that's one of the differences. And because of that, Presto can do certain things in a more adaptive and dynamic way. I think Spark has been evolving in that direction over the years, but it wasn't traditional like that. It's like when you schedule a stage of execution, you had to know like how many machines you're gonna run for that, and then once it's scheduled all the tasks, that's it. Like you have to it's limited by the choices made at that point. So other than that, I mean, at the end of the day, they are both, they can both do SQL. So all the standard operations that SQL does, both engines can do. It's just a matter of how the bottom of the engine is implemented. The other thing that Spark, I don't think it supports connectors to arbitrary systems, not in the same way that Presto does. So, or it didn't when I looked at it a couple of years ago. So.
Thank you.
Does Presto support joins from different systems, for example, from Mongo and Data Lake in some way?
Yeah, absolutely. So you, as I said, you can have in a single query, you can refer to multiple tables, and those tables can originate from different data sources. For example, you can say select, you can say select from events, and the events table is in Hive, join users, and the users table is in MySQL. And you can keep your dimension data. For example, it's very common. You keep dimension data that can slowly mutate in dimension data in a SQL database, and your event data in a data lake. You can join them on the fly without having to import all your user data into the data lake before you run your analysis.
Any more questions?
What happens if there is a fault in a node in the middle of an execution? How is the model of coping with it? I mean, if we have hundreds of nodes, the likelihood of it is not that scarce.
Yeah. So a couple of things. It's not as likely as you think. At Facebook, we run clusters of 800 machines, and we rarely saw failures of that sort. I mean, a machine can fail. Like if it's a temporary transient failure, it's typically due to a bug in Presto, and that's something that we track down and fix. A machine dying because the machine is bad or it's faulty, that's much less common. It's not something that happens all the time. Yeah, you may see one every few weeks or something, but that's an instantaneous unavailability for that node, and that's it. The majority of the time, things are run fine. Now, when that happens, any query that's currently scheduled to run on that machine or is touching that machine in some way will fail. And of course, you have to retry. It's not unlike other systems like, if you look at Vertica, Netezza, Oracle, like if one of those systems has a node that fails, your queries will fail. You have to restart them. Now, one thing to keep in mind that Presto tends to be so much faster than things like Hive that in the time that you can retry your query a couple of times, you'll still be running this the same underlying Hive query. So you're kind of trading that off. Like Hive can do more granular recovery for query executions, but they take so much longer that it doesn't really matter. You can retry any number of times and still be able to finish ahead with Presto. There are some things that we're looking into. We've been looking at it on and off, of adding the ability for the engine to deal with those failures automatically. It's like if part of a query fails in the middle of or one node fails, then be able to recover and continue from where it left off. That has a bunch of trade-offs, because in order to do that, you have to either be very granular and you do that by storing all the state as the query goes, which makes it inefficient to execute. So there's a trade-off there. Or you can be less granular, but then your recovery windows become coarser and potentially to a point where you have to restart the whole query. Right. But one thing to keep in mind is if you're running a large cluster, it's not likely that a given query is touching all the nodes. You may be scheduling on a few nodes. So if one node fails, if your query is not running on that node or it's not, hasn't been scheduled on that node, then it won't be affected.
Okay, if those are the final questions, then I thank Martin for the great presentation, and we'll see you all in the next meetup.
Thank you very much.
Bye. Thanks for having me.
Thanks.